Okay. So I start sharing my screen. Everyone can see this? Yes, no? Okay, cool. So today we're going to be talking about engineering and construction. We are Team 4087. We are based in New Orleans from Benjamin Franklin High School. Yes. So today we're kind of going to go over knowledge about construction project management and fundamentals about CAD, its uses and resources. So on the agenda for today is we're going to be talking about scheduling and then how we delegate and how our team is structured as far as engineering and construction go. And then we're going to go a bit into our design principles, some CAD and CAM, and then safety and competition life. Calvin, do you want to introduce yourself?
Sure. I'm Calvin Sieg. This year I'm the engineering director, so I'll be mostly in charge of design, CAD, and CAM. I also have experience of being the safety director, and I've been on the team since my freshman year.
And I am Grace. I've also been on the team since my freshman year, so this will be my 4th year on the team. My sophomore and junior years, I was our mechanical lead. And then last year, I was also planning and scheduling director. And this year, I'm going to be construction director. So a little bit about our team and like what gives you the right to start talking to us about this stuff, you know? So we're Team 4087. And we first went to Worlds in 2016 as a second pick bot. We were primarily defense. And since then, our team has been building and growing. And a large part of that is because of our design principles and what we've been doing with our CAD work. So last year, 2019, we got the Excellence in Engineering Award, and we were finalists at the Arkansas Regional, which advanced us to Worlds as a wild card, where we were finalists in the Hopper subdivision. And this year, we actually also, we were picked as the first pick, and then we won Arkansas Regionals. We were supposed to go to Worlds, but yeah. Alright, so construction and project management. So most of construction, I'm sure you would probably assume, happens like hands-on on the job. So that's where you're going to end up getting most of your experience. So I can tell you as much as I want, you know, measure twice, cut once, or like make sure like everything is square. But that's not really going to help you because, you know, you learn from doing and experiencing. So most of what I'm talking to you about construction today will be more of the behind the scenes project management side of things. And so what exactly does this entail? It includes scheduling, which is a really important part of FRC, especially now. And then we work on the day-to-day implementation of things. So delegating, and then like documenting things, communicating with others, because the structure of our team requires that, you know, that communication, that flow, as most things do. And also we work largely with engineering as far as the development of things go. So the big thing about scheduling, especially starting last year and now this year, is that first got rid of the bag. So if you don't exactly know what that means, at first ordinarily they would have 6 weeks to build the robot, and then once those 6 weeks are over, you take your robot and you put it in like a huge bag, and you can't touch the robot. You can work on things outside of the robot, but you cannot touch your robot except for like outreach purposes and like exhibitions and stuff, but you can't work on it. And so usually that gives you like a deadline. I have to get everything done by that 6 week mark. But then starting last year, they got rid of that deadline. And so now we have all the way up until competition to start working, which makes it seem like there's more time, makes it seem more favorable. But then you realize that like now you're overestimating the amount of time you have. You're not planning and scheduling. If you don't plan and schedule, you'll end up like not pacing yourself, and you'll end up with you bite off more than you can chew, if you know what I mean. So this year we started implementing the use of Gantt charts, which is what you see on the left over here. So this is what a lot of, I think, big companies use when they're like managing a project. So at first you like develop these milestones. So on the left here, you'll see like certain tasks we need to get done, and then we'll be like, okay, so this is when we need to get it done in order to like achieve our bigger goal. And then if you have to get it done by this day, that means that like leading up to that, you'll have like X amount of days to do it. And you kind of approximate. So you start with your key milestones, and then you kind of work backwards from there. And so this year we did that. We got like a huge expo board in our robotics room, and then we had all our officers sit down. And so like engineering was like, I want the chassis like design done by this day. And so we like threw the Post-it up there, and then we were like, okay, so this is when we need to get it done, and this is approximately how much time we need to do it. And you kind of find that organization there. And so we started this before build season, so it was kind of a general overview, a general outline. And then once the season starts, you start like asking yourself how it becomes specific to that season. Because maybe this season you need a hanger, or you need like a launcher, so it's just that general progression. And an important thing to note when you are making a schedule is that it's not definite. Which is like, you can't let your schedule dictate what you are doing. It's supposed to be a guideline, not like set in stone. Because you never know what comes up, crazy things happen. And you never know what might change in your process. Maybe you can't get your hands on a certain material. Maybe your shipment of parts comes in late. But that's generally how things go. And then you want to make sure you communicate your deadlines with people. Because if you don't communicate your deadlines, then people don't know when they're supposed to have things done for. And that's just not fun. So that brings us to our delegation and our team structure. So on our team, we have our separate directors. And so for our purposes today, we're going to be looking at engineering director and construction director. And then within those teams, they're like, we have the CAM manager, the battery master, and then 4 different development managers. So all of these, all the orange people that you see on the screen, they like report to the green people. And so you may be wondering why we have so many different development managers. And this is a thing that we have new for this year. So usually we just have like the officers of certain sub-teams. But this year we're splitting it up into silos, where we have like different people from different sub-teams working together towards a certain subsystem of the robot instead of just focusing on their sub-team, if you understand what I'm saying, which helps a lot with like the communication and like the working of a certain system, because you have like the same people working together to create, say, the hangar. So you have a group of people from construction to engineering to automation all working on that hangar, and it creates I guess more of a sense of ownership. Like if someone asks you at competition what you worked on, it can be like that part of the robot. I worked on the chassis, and then it just creates more commitment, I guess, more ownership of what you're doing. And so this organization based on subsystems has taken over our organization based on subteams, to foster a better communication between subteams. And then so a day in the workshop looks like, you walk in, we have like maybe 4 different subsystems at the time, and then you start assigning people to it. So like you're on the launcher and you're on the hangar, and it just keeps commitment and keeps people going well and gives them a job to do, And so within like these silos, we really need communication, because if the launcher subsystem and the hangar subsystem aren't like communicating and talking to each other, then you can end up with a launcher that's supposed to be like maybe in the same spot as the hangar is supposed to be, which wouldn't be ideal. So communication is a really important part of all things, but especially construction and engineering. So we're trying to implement like more daily updates, so progress checks, maybe like at the end of the day being like, okay, what did you plan for today? What did you actually get done today? And like what stopped you from like fulfilling all the plans that you were supposed to be doing? And that's like a good database for the future. Know where you can improve, where you fell short. And so we're also trying to create spreadsheets for prototyping, just as a way for like all the development managers to be like, this is where I am right now. This is where my progress is, and this is where we need to go. And also team updates. So in the past, we've had like our captain, when we finished like a day at work, they'll send out like, okay, this is what this sub-team did, and this is what this sub-team did. And so everybody has a general understanding of where we are and what our progress is. So everybody has a general better understanding. And also our technical binder, which is a thing that we have done this year and in past years. It's a really good way for judges in the pits to have like a visual as a guide for what you've done throughout the season. So as far as the technical binder goes, we usually have like a page for each like subsystem, and then it's like all the major decisions that went into making that, like different prototypes of it, or like maybe like this year our chassis, like why did we pick 8 wheels? Like why did we pick the wheels that we did? And it's just a good way to document things for future reference and for the judges. And so a lot of the times we end up working with engineering, which is really important. So we help them like plan things and implement them in our actual robot. So now I will pass the baton to Calvin.
Okie dokie. All right.
Do you need me to give you control of the thingy thing?
I got it. All right. So can you all see what I'm viewing? Alrighty. So engineering. Okay. What is engineering and what will you be doing? So engineering, you're going to be mostly in charge of the design of the robot through CAD, CAM. There's a lot of research involved, and there's a lot of working with construction. And the typical schedule that you're going to be looking at is very similar to construction, with like scheduling and documentation, but you'll also be responsible for all the prototypes and a lot of the research. So we'll just hop into that. Right here is a CAD model of last season's robot. And this is the hangar and the shooter that Grace was referring to. All right, so our approach and design principles. These are just some quick tips to keep in mind while you're going into designing the robot. Picking your battles, don't reinvent the wheel, and constant reiteration. All these basically saying that you're given an objective, you're given the game, and you need to think quickly and efficiently about how to achieve the problems that they set out for you. And so finding something that may be cool and it may be very useful, it could also be extremely complex and take a lot of time, research, and energy. So making it more simple and functional is definitely the way to go, unless you have huge amounts of resources, which a lot of teams don't. Don't reinvent the wheel. If you see something that you like or you have seen in previous seasons on your own robot, you can look at those for inspiration, and constant reiteration, that'll go into prototyping, which I'm going to talk about in just a bit. So brainstorming, research, and scheduling involved in that. On engineering, it's a lot more design-oriented and prototype-oriented. So usually when you get the game and you get the objectives and the tasks that your robot needs to perform, you will start to think and brainstorm collectively as a team about what will be the best way to achieve those goals. And then after you guys come up with a consensus of generally the direction that you want to go through, then you can start doing some research. But that general direction, it can be pretty flexible. A lot of times when you start to research and you start to design, you'll start to hit like speed bumps, sort of, and you'll want to reiterate, which goes into like the past slide of just constant reiteration. So prototyping. What our team does is you will start to think about all the resources that you have and all of the things that worked in the past. We'll get into it here. So you will first split into silos. Grace touched up on this. Split into your teams, and those teams will be assigned to a certain part of the robot. So for example, I have the drivetrain to the right, and start to accomplish and start to schedule that, and then notify the people in charge of scheduling, put it into the NAT charts. And once you have that set, then you can start going into research. So the biggest things that we look at for research are past games, past robots, and occasionally current season reveal videos. I'll start with the current season reveal videos. As a side note, that comes out later in the build process, and it's meant more for reiteration than for like inspiration at the beginning of it. So for inspiration at the beginning of the build season, where you're actually thinking about what prototypes you want to be making or what to base your prototypes off of. Looking at the past games with past robots are very useful. A good example was this past season, there was a component of the game where you had to climb climb a pull-up bar, basically. And so there were plenty of games in the past where robots had to achieve a similar task. And so looking at those, like how did other teams manage to climb this bar, showed a lot of different like perspectives, a lot of different ideas that you can incorporate and sort of create a hybrid of. Right, so more into research. So the two big research resources that you'll have are Chief Delphi, Robot in 3 Days. Those are besides the past game videos and past robot videos that you see. Robot in 3 Days is a really cool idea where there's a team, many times college students, who, as soon as they get the game, start right into engineering the robot and right into constructing it. And so they will many times document their progress and post it on forums like Chief Delphi, which is a forum for a lot of FIRST and a lot of technical questions for FIRST. They'll post their progress on forums like that. And then many times they'll also post videos on YouTube or hold live streams. At the end of those 3 days, they'll come out with their reveal video of their robot, showcasing what they did in like their final robot. And that is specifically oriented to the game for that season. So many times that's a very good resource to look into when you are like considering what to apply to your robot. Another useful resource for research, continuing on Chief Delphi, is models. Many times, say you have some motor and you don't know some of its statistics or some of the like power it can handle, going to Chief Delphi and like many times people in Chief Delphi will have models that you can put in, say, robot weight and whatever the motor you're using and sort of calculate what sort of power you need to be drawing, things like that. And then that'll come in very useful when you're continuing to prototype. And when you're prototyping, you're considering where certain parts will go on the whole robot as opposed to just individually. And then you need to start thinking about electronics management and where to place components to feed power to all of the mechanisms that you're designing and prototyping. Now, to what you will be using to design and prototype is CAD and CAM. Those are the two really big ones. Of course, you'll be using like pencil, paper, whiteboard for those sessions, but a lot of individual work will be done hardware that can run SolidWorks because it's a pretty demanding software. So I showed you a few CAD models before, one of the drivetrain and one of the robot, and those will be like skills necessary to make those will be taught in the off season, usually the fall semester leading up to build season, which occurs in the spring semester. And then similar to CAM, the skills necessary to learn that will be taught in about the same time. CAM is and on many times large scales. And 3D printers are also very useful for the prototyping process. All right, so I already sort of touched up on this, deciding on design fundamentals, what kind of mechanisms do you want. And then after you start to take all of the resources that you have and you start to prototype, you have to get back into reiteration. Once you apply it to your robot or just testing it out individually and you see a fault which you think you can improve upon, you many times go back to the drawing board, sit down with your team again and just think, how can we make this better? Many times going back, looking at other robots again, looking at Robot in 3 Days, what did they do to achieve success in the problem that you're facing? And then you go back and you prototype. Examples that we've had, say, like I have a gearbox and a motor set to the right. We've had problems with gearboxes in the past, and that was something that we had to go back and look at. And that was something that we did not address or really find out about until competition, where it becomes very, very difficult to replace a gearbox being nestled very far into the robot and having a lot of components. So you're going to prevent a lot of the failures and a lot of mechanical failure that you'll be facing in competition at this time in the prototyping stage. Yeah. All right. So moving into safety. So me being a safety director, I think 2 years ago, we'll be taking this. Our current safety director couldn't come today, but she made this wonderful set of slides. This applies a lot more to construction than engineering per se, because engineering you're going to be working a lot with, like on the computer, a lot of research. And many times construction will go into, engineering will go into construction after they design their prototypes and work with many of the construction engineers and managers there. And so it's important to keep in mind all of these safety rules. So I'll just go down, you can read this, but essentially you want to make sure you're wearing proper safety equipment. PPE is personal protective equipment, protective personal equipment. So like safety glasses, you always want to make sure that when you're working in an area with other people, that you have a space where you can work efficiently and safely without disturbing other people. If you're drilling something, or you're like, if you're drilling something or you're trying to pull something out, say a stuck piece of metal, and someone's right next to you, you risk their health and your health too, if you're not considering their workspace. Just keep in mind what you're doing. Always be attentive to, your area and your surroundings. Whenever you're about to use, say, a saw or something that's on a large scale, a larger tool, you need to signal to other members that you're going to be using that. If it's just you in the room, fine. But if there's other people, like just yelling that you're going to use the saw is a good way to signify to other people that you're about to like possibly endanger people in the direct vicinity of you. And so that gives them time to move away. Now, the last one, if you're feeling sick in any way, refrain from like doing these activities. That's also general health and general safety. If you have a cold and you come to the workshop and you're sneezing and coughing everywhere, you're probably going to get everyone else on the team sick. So just keep in mind, maybe ask the managers and ask the directors what you can do instead. If you're really feeling sick, let them know, and probably go and rest, because this can be pretty tiring going into the build season. Okay, what can cause injuries in robotics? Most of these injuries are caused by being careless. That is true. You also need to, a lot of these injuries can also be caused of not, like, lack of knowledge, lack of safety training. Something that we do is every season, it doesn't matter if you're a veteran or a new member, everybody needs to be certified on all of the tools, all of the power tools, from the saw to the drill. And it's somewhat lengthy, but it's very necessary to make sure that everybody knows the proper safety to handle those tools. We had a few occurrences last season where, although they were certified, they weren't completely in the know of what safety precautions you need to be taking when you're using a saw. And so what happened was they were cutting a shaft, and when you're dealing with small round pieces of metal, especially long pieces of metal, you can risk breaking the tool that you're using and injuring anybody else in the room. So he tried to cut the piece of metal, and the saw blade basically exploded. Luckily, no one was hurt. Not many people were in the area, but you just need to understand that everybody in the room needs to know the safety of each and every tool. Safety gear, do not horseplay there's no horseplaying in the workspace, in the workshop. That leads to injuries, and it leads to distractions, which lead to injuries. You can have fun, but you shouldn't be taking people's minds off of what they're doing. Not being supervised, there should always be a veteran member or a mentor, preferably a mentor, because they have much more experience than the veterans in the room whenever you're using a power tool. And then leaving equipment or machinery unsupervised. This can go into organization of all the tools and all of everything in the workshop. Everything should be organized. Everything should have a space. Nothing should be on the tables. And that not only helps with safety, but it also helps all the other team members, especially on construction and engineering, with the ease of prototyping and the ease of assembling the final robot, because you don't need to be looking everywhere for, say, a tiny screw. Yeah. How to maintain a safe environment. So this is on the right, a job safety analysis. This is something we used in past years, where you basically fill out what you're going to do, and then check off what precautions you're taking to ensure safety. And it's pretty simple. You just like either circle what you're about to do or list what you're about to do, and then choose the hazards, choose the controls, write your date, sign it, and you're good. It takes very little time, and it helps a lot in getting you to understand what precautions you should be taking, and just like list it through your head and make sure that you are ready to use whatever tool or yeah. A safety manual is also pretty useful. This is very useful in terms of like documenting all the safety that your team is taking. Procedures, how to use tools, protocols when something goes wrong, basic first aid. Whenever something happens, you need to notify either the safety manager, any of the veterans, somebody in charge, so that they can treat it right away. And those are the people that are experienced and know and have like went over the safety manual more than once, which everybody should do. And then after that, so up to the safety manual, certifying team members on necessary tools. I talked about that. And then ensuring all the team members know all the safety procedures, create documentation for injury reports. That one's also very, very useful, and that can go along with the safety manual in terms of documentation. Example of that happening, the last team captain, or team president, for our team was hit by the robot during practice driving. And then he was okay, but he got like hit in the shin with the robot. And then you fill out a form very similar to the job safety analysis. It's just like a job injury report instead, where you fill out what happened, why it happened, what can you do to prevent it next time, and just getting people to understand like what went wrong, what you can do to prevent it in the future. All right, competition life. I can hand it over to Grace for this one.
Now I'm gonna tell you just a couple of quick notes about how things work at competition. So one really important thing to remember and to note is a pit crew, because if you bring a lot of people to competition, everybody's going to want to be in the pit, and if you have everyone in the pit, then you are not efficient at all. So you want to limit the number of people who are in the pit so that you can prevent like overflow, prevent crowding, so when you need to work, you have room to work. Very important. I put it in all caps. Don't overcrowd the pit. And so since you have extra people, you can always assign people to like do things like scouting, which is like sitting in the stands, watching other robots, seeing who might be good in an alliance with you, certain robots' strengths, certain robots' weaknesses, just the whole shebang. Also important to have a battery master, which is something that I also did last year. So we kept a log of batteries. We have a battery beak, so it tells you the charge of the battery before you start. So we log how much battery it has before we start, and then how much battery it has after we finish. And so we kind of have a general idea, is this battery good? We labeled all the batteries with like letters, and it gives us a good idea, like, is this battery still a good battery? Do we need to throw it out? Is it like losing its like battery life? Which is a really important thing to note, just so you don't brown out in the middle of a match. I put the wrong word here. I meant to put make your bot stand out. But anyways, make your bot stand out. If in your like construction or like designing process, we have this little shrug. I don't know if you can see it. It's that green plate on the side of the robot. And it really makes other teams like if you do something that's really cool, they'll like remember you. They'll remember that bot with like the shrug, the green shrug. That's us. And people like remember it. It's memorable and it'll let them know who you are. So if they think you're good, it's like ingrained in their brains and they'll be like, we want that team. And we like that. And I think that is it. So at this time, we'll take any questions, comments, or concerns. Okay, so one thing that I was thinking about earlier was like how long generally the design process takes. And I think like most years it varies, which is something that we should probably work on. But like there's no set amount of time. Like one year we were almost done with week 4 and then we were like, we don't like our robot. We're gonna do something new. And so we like scrapped half of our robot and we ended up like perfectly fine. And it was good. So you know, there's no set timeline, but you should try to stay on schedule. Please. Can we innovate and make the robot fly? I'm not sure that's within first rules at the moment, but we will not lose hope. Yeah, you can always add extra wheels on the robot. Do some cool stuff. I don't know. If you can make your robot fly, that's like really good on you.
I hope one day we get to do a game, first designs a game like that revolves around drones or something like that.
I plan on making an aerospace club.
That's cool. You should do that. And then when you do, tell us about it because I want to hear more about that.
I absolutely.
I just want to drop a plane from space.
What school do you go to?
I used to go to Harriet Tubman, but I go here now. Franklin.
Ah, fun.
I'll definitely be willing to help you start that club in that case.
Does anyone else have questions or more comments or concerns?
Generally, when you have your teammates or when you have the other people in your team, how many are actively working at a single time? Because for our team, we struggle a lot with getting people first off to learn the necessary things for, necessary to build the hardware or to program. And then the other part is trying to get them to actually work on the, the task at hand. So how do you deal with that as a team?
So I think our general structure, because we have like a lot of subsystems, we have a lot of different aspects working at once. So for each subsystem, we'll have like maybe one like lead development manager working on it, and then like 2 other people helping them, so that they can have their fair contribution of ideas. Generally, that keeps people pretty busy. At least unless they start messing around, which happens. Did that answer your question? Or Calvin, do you want to jump in?
A lot? Okay. I think I'll just jump in a little bit. A lot of the like training per se will be in the off season before you start to work on the robot. It's something that we do, and it's something that has helped us. So we're not struggling to teach someone how to use a certain tool or teach someone how to use a certain application that we have. During the season, if you're trying to teach, I think I just agree with Grace, the subsystems and just having people like watch over and have everybody contribute their fair share of ideas.
All right, thank you.
Thank you. Anything else?
For just like a little reference, I didn't go into so much actually getting CAD and working with, like, getting it. Is there any concern about getting access to the resources, or?
Do you as a team use SolidWorks or Fusion 360 or Onshape or different?
We use Onshape. We previously used SolidWorks, but it became difficult for people who didn't have the hardware that could run SolidWorks. And Onshape is cloud-based and also allowed for like group collaboration on a single document or a single like piece mechanism.
Does Onshape require like any special setup? Like I've been using Fusion 360 for a while, and it requires like you to specifically put in that you're a student in order to get a free license for 2 years or however much. Is Onshape similar?
I believe Onshape, there is something very similar where you do put in some student license, or I mean some like verification that you're a student or you're some teacher. However, I do know that you can sign up and I think just start on Onshape. I did see something about Onshape licensing for students, but I also remember being able to just go onto the website and sign up. And then you also get access to the Onshape has classes taught by engineers and the Onshape team, which I think is also accessible to individuals without like student licensing.
All right, thank you.
And just to add on to that, I think I knew they had this last season, but partnership with First, Onshape had a partnership with First where First students could have access to Onshape just by signing up with. Yep, it's still here.
All right, thank you.
No problem.
All right. Well, if there are no more questions, one final call. I'll wait like a minute. Okay, that wasn't a minute, but it was long enough and it was uneventful. So thank you all for coming. We appreciate having you here, and good luck.